Hey everyone, let's try to solve one of the most frequently asked questions in an interview for any C# developer, right from a fresher to the senior management. Only change you will see is the way of solving the problem. You know, do you have any idea what is the worst way to solve this problem? Please put it in the comment. I want to see which approach you think is the worst way to solve the problem. The approach is array.sort. I mean, when you're creating an application, using this is wonderful because it is such an optimized and beautifully implemented internally. But the moment you use this, the moment you write this line of code on Notepad or wherever they allow, you are going to attract so many follow-up questions. The first one will be because I have personally fallen into this trap. And that's why I'm trying to, trying you to never get into this. That which sorting algorithm .NET is using internally. If you don't know anything about sorting algorithm and all, then I'm definitely coming up with a separate video where I'll explain all the sorting algorithm which we have. Because sometimes, especially in product-based companies, I've seen like they ask, especially if you're 3 to 5 years of experience, they can ask like, do you know what is the difference between a merge sort and quick sort and so on. Okay, even if let's say you have some idea how it is actually internally implemented, still you'll have so many, follow-up questions. So there is no point of solving in a way. It might look very easy, right? We have just 2 line of code and you're definitely going to get the answer. Even if let's say, there is a matching index, you'll put a condition and you'll get passed through it. But the trouble is, how will you answer these things, right? In worst case, it becomes big of n square. How you solve it? How .NET is basically solving it. Since you have used this method, these questions will be follow up, right? So the best possible way is definitely I'm gonna use. But just in case if somebody directly asking you in array.sort, which sorting algorithm .NET is using with array, then basic you can help them explain. Like let's say it uses quicksort, hipsort, and insertion sort collectively. Okay, how it actually resolve the problem. In worst case scenario, sometimes quickshort will take big of n square. And sometimes some other algorithm will take much less time. So .NET internally has implemented it such a beautiful way that by the end of it, by the time we get the final output, it is already optimized. We don't have to do much about it. That much explanation is more than enough. Only thing is the name is intro sort, okay, introspective sort, because internally .NET is doing all the introspection for us. But we don't want to get into that, right? We want to solve this problem and move on. And we also want to, give an impression that I'm the right candidate who know which algorithm is to be used. So let's flip to Visual Studio. And today I'm going to avoid, brute force approach because the same, looping the entire array twice is definitely not the right approach. It will give big of n square and time complexity will be worst, right? So we'll use today two approaches. So let's flip to Visual Studio and let me show you how I will be solving or how I have been solving whenever I was asked this question. Okay, let's start with the understanding of problem statement. Given an integer array, we have to find the second largest number. But if you see here, 25 appears to be twice. So if you're not going to handle this situation, now, then whatever code you will write, 25 will be the second largest normally. But we will negate it through condition. We will add it. Let's understand the intuition, how we are going to solve it. So we have this array, right? What we will do, we need second largest. So first we will find the largest element. For that, we will run the loop and we'll find the largest number and we'll store in a variable. In the second loop, we will run the loop twice in different way. Okay. First, we will pass it through the entire array. We will traverse through each element of the array, and we'll figure out which is the largest one. And in the second pass, we will find the second largest. But we have to make sure that 25 doesn't come as a second largest, which it can if we don't handle the situation. Okay. Let's let's start understanding this through a try run. Now, here's the array. We have to find the largest one. So what we will do initially, we'll consider the first element of the array to be the largest one. Let's consider 12 is the largest one. Since we have not seen any other element, we are starting from here. We consider the first element to be the largest, which is possible, right? Now we will start from here and we will compare each value if that value is greater than 12 or not. The moment we find it, let's say in the second run, we will find it here, right? The 12 is less than 25. So we will update the largest value from 12 to 25 and we will continue looping through this. Even if let's say it reaches here, It is also 25, but it is not larger than 25. So largest will remain. Now in second pass, after first pass, we have got the value. In the second pass, here we are finding to second largest. Okay. Now again we will consider 12 to be the second largest. Okay. We will keep on moving through the array one by one unless we have reached a place which is greater than 12 or greater than the first element but lesser than the largest value. That's an important thing. Now let's code whatever we have discussed here. So in the first pass, as I said, we'll have a variable which will represent the largest value. And we don't have to assign a value uh, from this given array. We can, let's say int max or something. But let's, for the sake of simplicity, we will, uh, you know, assign the first value to be the largest one. Then we'll run the loop from 0 till the n, which is length of the array, and we'll see if there is any value within this array which is greater than the largest. If that's the case, means largest is not the one we considered, means the first element of the array is not the largest one. Now we have found the largest one, which is that particular element, right? Now in the second pass, we will try to find the second largest one. Since we have already updated the largest value, now we have got the largest value here. Now let's see how we check for the second largest. Suppose, we consider the second largest to be 0. And let's assume that this array is all non-zero element. Okay. Or you can even, consider the first element to be the second largest. That's totally fine too. Because end of it all, after the condition, we will anyways gonna find the solution, right? So let's create a flag which will represent if we have found the second largest or not. And why I'm doing that, you will realize when I'll be coding that. Okay. This is a very important reason why we are taking that value. Okay. So we'll traverse through the entire array and see
We'll
if
again
we traverse the entire array, right? This is going to be, this is what we are calling the second pass. This was the first pass, and this is the second pass, which we are doing currently. So here we'll check a condition if array of I, means the element we are at is not equal to largest, right? If this element, let's say we are at first position or second position or third position, and that is not equals to the largest, then we'll check another condition. First of all, they should not match. Let's say if we are, you know, we have got 25 and 25 twice, then we don't have to update the value, right? We'll ignore that. To ignore that value, we are using this condition. And now inside this condition, since using this, we have negated any duplicate value which we are going to find in the array. Now we'll have a condition if not found, okay, assuming we haven't found the any second largest value, and this element which we are in inside the loop is greater than second largest. Okay. So here our assumption that the first element or the second largest value is 0 was wrong. Since we have got it wrong here through this condition, we will update the second largest value to be the one we are at. So that particular index will become the second largest. Hmm. Have we found the second largest? Yes. So we will turn the flag to be true. Correct? Till now, I hope it's very clear. Now it's time to return the value. So let's return the value through return second largest. Right. And before then, we can a condition. If let's say if we couldn't find it, then we'll throw an exception that there is no second largest value exist. So that's the simplest possible way. Here, the time complexity will be O of 2n and space complexity will be O of 1. So sorted. Now let's move on to the optimal solution where we will try to find this in a single run. We will not use two for loop. First to finding the largest one and the second time to find the second largest one. Now we will try to do it in a single pass. Let's see how we do it. It's very simple. Now let's see how we can do it in a single pass. We don't have to run through the entire loop twice. So what we will do, we'll again take two variables. One represents the largest, second will represent the second largest, right? And this time we will solely focus on the largest one. The moment we find the largest one, we will update the second largest with the previous largest, which we had assumed. Let me explain you through the try run. Okay, so this is the array which we are working with, correct? Now, we are assuming that both of them will be a very small number. Okay, that's to start with. Now, the moment we reach at the first index, we'll see is the largest greater than the current largest, which is minus negative. Is it greater than 12? Yes. So we will update the largest. And now second largest will be remain where it is. Okay. Logically, largest will be replaced by minus negativity. But the thing is, since they represent both value in the in the first index, you will not find any, sort of changes. No. And when we reaches to 7 at index 1, then we will check if 7 is less than 12. Means now the largest value will remain as it is since it is not no greater than 12, but second largest will be given the value which we have found in the first index since it was negative, right? When we reaches here, we will again check if 25 is greater than 12, which currently is 12, which currently is the largest one, which we found out to be true. Then the largest will become 25 and second largest will start representing 12. How we actually Let's start solving this problem. Then you'll have a very clear idea what we are actually doing. Let's start with creating two variable int largest equals to int dot min value. Okay, we are doing the smallest value possible, and then int second largest will also point out to same. Okay, so both we have considered the minimum value since we have not touched the array yet. Now bool found again for the second largest if we have found any second largest or not, because there are condition which I just talked about. So we might not find the second largest. All the element of the array represent the same value, then only we can find is the first largest, right? So that condition can be there. So just in order to, in the coding, we try to avoid as much, edge cases as much we can. So given array, so we'll apply a loop and we'll check if this element, which is currently at the first element, is greater than largest. Since we have considered the minimum value possible, it will be the true. Yeah, the value will be that. So we will update the second largest with currently largest element, which is both of them are same. But if let's say we traverse through the array and if it reaches here, then you'll start seeing the difference, right? At that time, 12 will be smaller than 25 and 7 will be smaller than 12. So that's where largest will be occupied by 25 and the second largest will be occupied by 12. Now, since we have updated the second largest with the largest value, largest will become the one we have found in the element index of that particular value in the array. Okay, let's consider this to be case 1. Now, else if there is a condition where x is not the largest, x is no longer the largest, and sorry, and we have not found the second largest yet, right? Or x is greater than second largest. What does this mean? Now, in order to understand this condition, let's understand what we have done till now. In the case 1, we found the largest element. Since we started both largest and second largest to be the minimum value possible in an integer in C# or .NET, right? Then we basically navigated through each element of the array. And wherever this x is represented now, currently, let's say in the first pass, it is at the element 0. And checking if that is greater than largest or not. So first one is representing 12. So 12 obviously is the largest number, right? So assign that largest to uh, we will assign that largest with this x, which is 12. So currently largest will be 12 and second largest will remain minus negative least value which is possible. And in the second case, what we are doing is first we are checking if the current value is not equal to the largest, right? Means let's say if we have reached at 7 and 7 is not greater than largest. Okay, then not equal to largest, because we want to negate the both element representing, let's say, 25, that value. And then either we haven't found any valid second largest here, or the current value is greater than existing second largest, right? Let's say we haven't find any element out there. Let's say all of them represents 25. Then it makes no sense to find a second one, because that one will means that particular array will represent only first largest. There is no second largest in that case. Or x is greater than second largest. Now we have found a value which is greater than second largest, but it is not equal to largest. Then here we will update the second largest value with this x, and we will turn the found to be true. Okay. Now we can return the second largest. Now, since we found that second largest, we'll return it. Now, just look at the dry run once again to make things even more clear. We started with both of them representing minus the smallest possible value for an integer. And we saw first 12. Then we assigned that to be the largest value. So 12 became the largest one, right? And when it reaches here, we check if it is equal to 12 or greater than equal to or 12 or not. We found out no, it's not greater than or equal to 12. So means this value will be occupied with second largest. Now when we reached here, we saw this 25 is greater than 12, means this 25 will become the largest one and 12 will become the second largest. And so on we continued. By the end, we realized that 25 remained the largest value and the second largest value was 21. Okay, so try solving this on your own. Try practicing these questions, because when you're in an interview in a dense environment, you might end up, missing out on creating variables. Why we need Boolean? Because that's a very important thing, right? Without Boolean, how will you represent that you haven't even find any second largest? If let's say you are doing a code in online compiler, and the test case is like the entire array represents 25 or of the same value, there is no possibility of second value. We have to negate that, right? Otherwise your condition will fail. So these kind of things, with this intuition, I hope things are clear. If anything, let me know in the comments. And one thing, if you can let me know in the comments, it will be really nice to have an interactive session, that why we are not assigning x to the largest first and then assigning second largest to the largest. What I mean is that why are we not doing this, that we are first assigning this and then assigning the second largest? Please let me know in the comments. I want to see how many of you actually think while coding. Thank you. Let's meet you in the next coding question, which is frequently asked.